70 kilo person, right? You can lose maybe about 10 to 15% of your body weight in water before you're basically on the floor, and someone is putting an IV in, right? So that's an incredible amount of fluid. That's like 7 to 10 liters, right? I mean, that's almost like 20 pounds worth of fluid that you can dump on the asphalt before you're literally dead, almost dead. That being said, while we do have a lot of water reserve, at about a 2% loss, our performance begins to decline. At 5% loss, we're just not even performing like we think we should be performing. And by the time you get past the 5% weight loss, your risk of having some sort of heat illness goes up exponentially, right? And not only, can you have a heat stroke or heat exhaustion, but as you dehydrate, your small intestine basically starts to fall apart. And it falls apart because one, there's not enough fluid or blood to, infuse all those little capillary beds to maintain cohesion. Two, as you start to get hot and your body temperature rises, a lot of the what are called tight junction proteins, the proteins in between the cells that make up your small intestine, they start to fall apart. It's like the mortar between your bricks start to break down. And when that happens, the primary function of the small intestine, which is to keep bad tissue in your gut outside of your body, starts to fail. And a lot of triathletes, they end up feeling like crap because they're actually getting low grade of toxemia, they're becoming septic, right? They're going into bacterial shock. So there's a lot of bad stuff that can happen with dehydration. And in the same way that we can survive for days without food, or weeks without food, but only days without water, performance is very much the same, right? And so if all you did in Ironman was disregard your fuel and just work to stay hydrated, it's more than likely that you would have enough fat and glycogen reserves to get you through most of the day, right? And the only thing that you would need to do is maintain enough carbohydrate to maintain your blood sugar so that you wouldn't become hypoglycemic, right? With respect to calories, you've got to be incredibly fit or incredibly large to ever burn more than 1,000 calories an hour. And I think a lot of people mistake their exertion level or their feeling of intensity for their actual caloric expenditure. At the Tour de France, for example, some of the fittest athletes in the world, right? It's rare to see these guys ever burn more than 800 calories per hour, right? Not to say that you couldn't compete in the Tour de France, but to say that 1,000 calorie burn rate is incredible. And one thing to realize about exercising that hard is anytime you exercise at a very, very high intensity, not only are you potentially burning a lot of calories, but you're generating a ton of heat, right? And you're generating a ton of heat because the body is only about 20 to 25% efficient. So for every 100 calories that you burn, only about 20 to 25 of those calories actually results in forward movement. The other 75 calories or 80 calories just turns into heat, right? It literally just boils in blood. And that's why we sweat. Right? So let's look at this example. In the heat, right, you can burn, let's say 800 calories an hour. Right? That's if you're top end. Let's also say at 800 calories an hour, you're producing the kind of heat that would literally require 2.5 liters to 3 liters of sweat an hour to cool down, right? So you can actually go through all these little thermodynamic calculations and figure out how much water you would have to pour on this engine to keep it cooler, to literally keep it from spontaneously self-combusting, right? At 2.5 liters per hour, right? That's literally like 5 small water bottles that you've got to be drinking per hour. And most people aren't drinking that much. Mm-hmm. Let's say that the highest gastric empty rate, so the fastest the stomach can empty fluid is at 2.5 liter rate, right? And that would be with pure water. What's really interesting is that if you get about 4% solution, you can still get about 2.5 liters per hour emptying rate. But once you get past 4%, which is 4 grams per 100 mil, or 40 grams per liter, or 160 calories per liter, or 80 calories per half liter, right? There's not a lot of calories, right? Once you get past that, the ability for the stomach to empty actually slows down. So it might drop down to about 1.8 liters, so there's about a 30% drop, right? So let's say there's a 4% solution. I'm sorry, I don't have like a chalkboard. But let's say I have 80 calories per bottle, and that's the same solution as scratch. Well, at 2.5 liters per hour, that's what I was drinking, I could get in 100 grams of carbohydrate in an hour. Right? And I could also stay hydrated. That's 400 calories an hour. Right? And the general rule of thumb, if you go through all the origami and all the math, is that if you're always replacing at least half of the calories that you're actually burning, you're going to be just fine for prolonged exercise lasting 5 to 10 hours. Right? So what we know is that for even the most elite athletes, that if all they did was drink their calories with a 4% solution, a very low calorie solution, they wouldn't actually have to eat anything. Right? And on the very, very hot days in the tour, what you see is that the guys eat very little, but they drink a ton. Right? So we prioritize hydration first. We normally can get the calories or exceed the calories that way. But if we need more calories than what that low concentration can afford, the secondary question is, do we add more calories to that drink? And the answer is no. The answer is no, because if you add more calories to that drink, you actually slow down the emptying rate of the stomach, and you actually also slow down the absorption across the small intestine.
So because when I've been